Hello students, welcome to World of Chemistry. This is Dr. Vikram Panchal and I am dealing with chemical kinetics. This is lecture number 13 on this topic. In previous lecture, I was discussing about integrated rate law, first law and numericals related to first law, first order. Okay, now again we'll take numerical on the same order. So let us start. The reaction is N2O5 which decompose to give NO2 and oxygen. Okay, here given is a rate constant 5 into 10 raised to minus 4 and the unit is second inverse. Well, from the unit only we come to know that this is first order reaction. Okay, and initial concentration of N2O5 is given, that is 0.25 molar. Now question is, find out initial rate of reaction. So for initial rate of reaction, we will write differential rate law. Okay, so for this reaction, differential rate law would be that is minus d N2O5 upon dt is equal to K into N2O5 raised to x. As it is first order reaction, x is equal to 1 and this is initial rate of reaction, and therefore this is equal to K is given 5 into 10 raised to minus 4 into initial concentration of N2O5, which is 0.25, and the unit will be mole per liter per second. Okay, and this is equal to, you know, that 5 into 0.25, whatever is the answer. Okay, that you can calculate easily. Now second question, this answer I will leave it to you because you should calculate you by yourself. Okay, I'm giving you just hint. Second question which is asked about this is half-life period. You have to find out half-life period, and for that the equation is, for first order, half-life period is equal to 0.693 upon K. As the unit of K is second inverse, the unit of half-life period will be second. And here you have to put the value of K. So 0.693 upon 5 into 10 raised to minus 4. This will be your answer. It will be second. Okay. Next is the next question about this numerical is, what time will be required for completion of 75% of the reaction. Okay, here initial concentration of N2O5 is given, that is 0.25 molar, which we consider C0, that is initial concentration or 100% concentration of N2O5. Now N2O5 at time t, which is C, or it is equal to A minus X, is equal to 25% left, because 75% is completed. So 25% left of initial concentration, that is 0.25. Okay, so C or A minus X is equal to 25 multiplied by 0.25 upon 100. Okay, so now we have to write the integration rate law for first order, which is integrated rate law for first order, and that is t is equal to, because we want to find out time, so we will make t as a subject, upon k log C0 upon C or A upon A minus X. So t is equal to 2.303 upon the value of k is 5 into 10 raised to minus 4 log 0.25 is initial concentration, and upon 0.25 into 25, and 100 will be on numerator. Okay, and then you have to find out t. Okay, see 0.25 0.25 will be cancelled, and 100 upon 25 is 4. So you should know what is log 4, and then you can find out the answer. So this way you can find out seconds required to complete 75% of the reaction. Okay, next question for the same numerical is, what will be the concentration of N2O5 and NO2 after 30 minutes from the start of the reaction, or from the beginning of the reaction. So here time is given, and now you have to find out concentration of N2O5 and NO2 after 30 minutes. So what is given? C0, initial concentration, and that is 0.25 molar. Then you are given K is 5 into 10 raised to minus 4 second inverse. Okay, you have to find T is also given, that is 30 minutes. As the unit of K is second inverse, so you have to convert these minutes into seconds, so 30 into 60 second, and then you have to find out C. Okay, so again you have to put integrated rate law. So K is equal to 2.303 upon T log C0 upon C. Okay, so here if you put values of all, then we will get 5 into 10 raised to minus 4 is equal to 2.303 upon 30 into 60 log 0.25 upon C. Okay, now we want to find out C. So for that we will have to change the sides. So we will take all this on the 2.303 upon 30 into 60 on the side of K. So now we write log 0.25 upon C is equal to 5 into 10 raised to minus 4 into 30 into 60 upon 2.303. Okay, and then here you will write log 0.25 minus log C is equal to this one, and this will come roughly about 0.3902. Okay, now you know log 0.25, that is bar 1.3979 minus log C. Okay, then log C is equal to bar 1.3979 minus 0.3902. Okay, so that is equal to bar 1.0072. Now to find out C, you have to take anti-log of bar 1.0072. So C is equal to anti-log of bar 1.0072. Whatever will be the answer, okay, it will be 0 point something. This is N2O5 concentration. So C is concentration of N2O5 after 30 minutes. Okay, now we write N2O5 gives twice NO2 plus half O2 gas. So for this reaction, we will put initial concentration, that is C0, or A is equal to 0.25, it is given. Okay, final concentration after 30 minutes, where T is equal to 30 minutes, there it is A minus X or C, which is given, which you will find out. Okay, now at this time the concentration of NO2 will be 2x and concentration of oxygen will be x by 2. So if you know C, then you can find out A, and you know A, so you can find out x from this one. Okay, so x will be C, A minus C. So x is equal to A minus C. Okay, and from this you can put this value over here, so you will get concentration of oxygen after 30 minutes as well as concentration of NO2 after 30 minutes, and C is the concentration of N2O5 after 30 minutes. So this way you can try and find out all answers, please. Thank you so much.